In previous videos, we learned to take a trig function, specifically sine and cosine, and perform transformations. So in this video, we want to take that idea of being able to change the shape and location of a sine or cosine function and use it to model something. And here's the example we're going to use. The normal monthly temperature in degrees Fahrenheit in Albany, New York for 6 months is given in the table. So we're given this data here. And so what we want to do is we want to use this data and to create a trigonometric function to model the data. And then we're going to use that model to find the normal temperature in December. Not given there. Okay, so let's go ahead and to get a visual of this, let's make a little graph of it. So let's see here. All right, now we go up to about 72, so let's see here. 10, 20, 30, 40, 50, 60, 70, 80. So this is going to be temp. So 10, 20, 30, 40, 50, 60, 70, 80. And then we have to have our month. And this one you kind of have to think about. There's two ways we could do it. Either we could make January be x equals 1, or we could have January be x equals 0. X equals 0 is a little bit easier to work with as our starting point. However, thinking about it, we always associate January with the number 1. But in this case, because we're making the model, I'm just going to go ahead and say January is 0. So then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That should be enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be February, March, April, May, June, July, August, September, October, November. So then December would be 11 over here. All right, so let's plot our data. So January is 21, so January would be about 21. March is 34, so March is about 34. Again, this is just a sketch, doesn't have to be super accurate. May is 58. July is 72. September is 61. And November is 40. Okay, so when you look at this data, of course you have to interpret it whether or not it is a trig function. It's telling us to do a trig function, so you can kind of see that this thing is coming down here and looping down and kind of coming down here. Starting to go that way. So you can see that it is a trig function, or we could use a trig function to model this data. Good. All right, now we have two choices as far as our trigonometric function that we're going to model. We can either use y equals d plus a times the cosine of b times x minus c, or we can use y equals d plus a times the sine of b times x minus c. Okay, so we have to choose either cosine or sine, and we'll talk about that here real soon about which one we'll choose. But for both of them, for all three, or for both of these trigonometric functions, d, a, and b are going to be exactly the same. The difference is going to come whether we choose cosine or sine, and it's the c, what kind of horizontal translation we'll have to perform. So that's when the decision comes in. So let's go ahead and get the other parts of this. The first two are pretty easy. The first is amplitude. That's our A. And amplitude is simply capital M minus little m over 2. So it might have been a while back, but capital M is our max value, our little m is our minimum value. So you subtract those two and you divide by 2. So we go to our table and our max value is 72. Our minimum value is 21. So we have 72 minus 21 over 2, which ends up being an A of, what is that? So 25.5. So we might need a calculator for some of this stuff. I think that one wasn't so bad. 25.5, because you end up with 51 divided by 2, so we can do that. Okay, the other one that's pretty easy to get is our vertical translation. So let's go ahead and write that over here, vertical. So our vertical translation is just D equals capital M plus little m over 2. So that's 72 plus 21 over 2. So this ends up being 93 divided by 2. So that's 46.5. Good. I guess I should take a step back and, kind of explain what we're trying to do here. So remember that when you have a basic trig function, like sine or cosine, let's choose cosine here. There's our cosine function. This cosine function only goes from 1 to -1, and it starts at 1, it goes negative, comes back up to 1 over a course of 2 pi. And so what we want to do is we want to take this trig function, whether we choose sine or cosine, and move it and change the shape so it looks more like this. And we have 4 things we can do. We can change its amplitude, we can change its period, we can change its vertical translation and its horizontal translation. So we can make it bigger or smaller, we can stretch it out or squeeze it together, and we can move it up and down and left and right. And so what we're trying to do is we're trying to take that trig function and make it look like this. And so the first 2 things we've done is we've changed the amplitude. So instead of having an amplitude going from 1 to -1, we now have an amplitude that goes from 25.5 to -25.5. Then the next thing we did was we moved it up, and we found out that, well, instead of being an axis of oscillation of around 0, we want an axis of oscillation around 46.5. And if I actually go to my graph, 46.5, that seems like, oh, that would be about right where we would put our axis of oscillation. So we've already done 2 things to modify the shape. Now the next thing we need to do is we need to change the period. Okay, so our period. So remember, period is equal to 2 pi over b. Now the period is normally 2 pi, like that would be 2 pi. And of course, we're not going from 0 to 2 pi, we're going from 0 to, well, in this case, we want to go all the way to 11. And so we got to think about how we're going to change that 2 pi to get a period that matches this. Now sometimes you can use logic. In this case, it makes sense that because we're talking about a calendar year, that our period would have to be 12. Sometimes we have to kind of do a calculation. And so one thing to do that makes it easy is our period is equal to 2 times our max month minus our min month. And what that does for us is, if you think about it, is when we have a period, we're doing one full cycle. So if we were to start at the bottom, go to the top, and go back down to the bottom, that would be 1 period. Well, sometimes you don't have a data for 1 full period, like in this case. So an easier thing to do is say, well, what is our minimum? That happens at 0. What is our maximum? That happens at 6. And if I subtract those two, that will be half a period. Then if I multiply it by 2, I get a full period. So it's actually going to be 2 times 6 minus 0, which is 12. So then I take this 12, go back, and I end up with 12 equals 2 pi over b. And so we end up with b is 2 pi over 12, which equals pi over 6. And so that is going to be our